Hi everyone, welcome. Welcome, everybody. You have any questions, please feel free to ask. You guys can have your unit circle handy with you.
Hello.
Yes, hi. Hi, Lee.
Professor.
Yes.
I was just signing at the meeting.
All right, sounds good. How we doing?
Good, how are you?
Pretty good. Yeah, getting ready.
Great.
Hi, Christina. Welcome. We can hear you. All right, everyone. Let's continue with our lecture. Yesterday, we started 6.3, properties of trig functions, and we stopped at looking at the function in their domains and range or ranges. All right, so notice we have the trig functions, and also we have the unit circle right there. And from the unit circle, we can get the domain and the range. We said about the sine and cosine, both of them, the domain are from negative infinity to infinity, and their ranges are from -1 to 1. So let's understand why is that. Why the domain is from negative infinity to positive infinity is because no matter which value of theta you guys plug in your calculator, you're always going to get a value or output value, which is going to be the range between -1 and 1, included -1 and 1. That applies for the sine and cosine. So let's continue with the tangent. Notice the tangent going over the unit circle. If we notice the tangent is y over x, which is the sine over cosine. So what is y over x? Is 1 over 0, which is undefined. Notice tangent is undefined in pi over 2, which is 90 degrees. And also it's undefined in 3 pi over 2. It's also undefined. And notice 3 pi over 2 is a multiple of pi over 2, by the way. So if we go back to the tangent function, notice that the domain is all the numbers except when theta is not equal to an odd multiple of pi over 2. And notice also that the range for the tangent is all the numbers. So it might be some questions here, but next section, we're gonna start graphing all these functions, and it's gonna be cleared about the domain and the range. We're gonna have a better idea. So the tangent, again, the range is from negative infinity to positive infinity, okay? So let's continue with the cosecant. cosecant of theta. The cosecant of theta, if we go back to the definition of the cosecant is the reciprocal of the sine. So the cosecant, since it's the reciprocal of the sine, the cosecant does not exist at 0 and pi. So the cosecant, the domain of the cosecant is all the numbers except when we have an even multiple of pi. So in the range, notice the range is from negative infinity to -1, union from 1 to infinity. Why is that? Why do we have the range given that way for the cosecant? Because the cosecant, as we said, is the reciprocal of the sine. So in this domain, it might be right now a little bit visualizing it right now, but next section, as I said, we're going to be able to grab cosecant, and we'll see why the domain is in this form, by the way. And one of the reasons is because, again, the cosecant is the reciprocal of the sine, all right? So notice if we continue with the secant, since the secant is the reciprocal of the cosecant, and notice if we go back to the secant, here is the reciprocal of the cosine right here, all right? And the secant also, the domain is all the numbers except for odd multiples of pi over 2. And also for the secant, the range is from negative infinity to -1, union 1 to infinity. Why is that again? Because the secant is the reciprocal of the cosine. And last, we have the cotangent. The cotangent, which is the reciprocal, by the way, of the tangent. And the domain of the cotangent is the same as the domain of the cosecant, by the way. The domain will be all numbers except when theta is different from even multiples of pi. And for the cotangent also, the range is from negative infinity to infinity, all right? So that would be the domain and range. So let's go over it. It says determine the period of the trig functions. All right, for the sine and cosine. For the sine and cosine, the period is 2 pi. What is the meaning of the period, by the way? Okay, so it means that when they stop and start repeating again. So we're going to learn in the next section that when we start graphing sine and cosine, they start, we're going to start at 0, and one cycle ends at 2 pi. The same for the cosine. And from there, it starts repeating. Start repeating again. The sine and cosine start repeating at 2 pi. It starts all over again. But notice for the tangent, the period is pi. Why the tangent is pi? Because we said that it is undefined at pi over 2 and 3 pi over 2. So at pi over 2 and 3 pi over 2, the tangent is undefined. So the period of the tangent is pi. The cosecant, which is the reciprocal of the sine, also the period is 2 pi. And also the secant, which is the reciprocal of the cosine, is also, the period is 2 pi. And the cotangent, which is the reciprocal of the tangent, is the period is pi. Okay, so again, the period is when the waveforms complete one cycle and start repeating again. That's what the period is. Ready? So let's continue with the next page. It says here, let me focus right here. All right, so I did a couple of these exercises, but let's go over here, right? It says, find the exact values do not use calculators, all right? So let's concentrate on A right here. It says sine of 405 degrees. Let me focus right here. Right there. All right, notice we're not using the calculator. So sine of 405 degrees. So here we're gonna be using the unit circle. So we know that sine of 105 is more than 360 degrees. So what we're gonna do is we're gonna subtract 360. And when we subtract 360, notice that we're left with 45 degrees. So sine of 405 degrees is the same as sine of 45 degrees. And if you look at your unit circle, sine of 45 degrees is square root 2 divided by 2. Ready? Okay. So by the way, when we subtract, when the given angle is more than one period, and for this case, we subtract 360 and we end up with sine of 405 equals to sine of 45 degrees. We said that those two are the same. These two angles are known as coterminal angle. Let me write it down here. These two angles are known as coterminal angles. Coterminal angles. All right. So notice if we continue with B here, now it's given cosine of 33 pi over 4. Again, 33 pi over 4 is more than 2 pi. So any value less than 2 pi for the cosine and sine, either we can find it by using the unit circle or we can find it by using the calculator in case that specific value is not on the unit circle. But we're gonna do the same, we're gonna apply the same method we apply for A. So notice 33 pi over 4 is more than 2 pi. So we're gonna start subtracting 2 pi to 33 pi over 4. But notice to make our life a little bit easier, let me rewrite 2 pi with the denominator of 4. If I rewrite 2 pi is the same as 8 pi divided by 4. And if we keep subtracting 33 pi divided by 4, and I'm gonna do it right here. Let me get an extra piece of paper right here. But you guys can do it on your own also, but let me get here. Notice if we start with 33 pi divided by 4 minus 8 pi divided by 4, all right? So if we keep doing the same here, you guys, and you guys can do it right there. What is 33 minus 8? That would be what? 25 pi divided by 4. And if we keep subtracting, or another way to do it, you guys, also is how many times 4 goes into 33, which is 8, and how many 4s are left? And if you notice, 4 goes into 33 8 times, because 4 times 8 is 32, but since we have 33 pi, 1 pi is left, which is pi over 4 right here. That's the other way that we can do it, and that can be done faster. Or you can subtract 2 pi every single time until you get to cosine of pi over 4. So again, cosine of 33 pi over 4 equals to cosine of pi over 4. These two angles are coterminal angles, by the way. And what is cosine of pi over 4? Well, cosine of pi over 4, we can use our unit circle to find the answer. And again, it is square root 2 divided by 2. All right, so let me see if anybody has any questions since that we're fine so far. So now let's try C. Notice C is tangent of 19 pi over 6. Again, remember the period of the tangent. The period of the tangent is pi. So you can do the same as we did, subtract pi to 19 pi over 6, or rewrite pi as 6 pi over 6, and from there start subtracting. Or we can ask ourselves, how many times 6 goes into 19? So that would be 3 times, right? And how many are left? Well, 3 times 6 is 18, but we have 19, so 1 pi is left, right? So this pi, which is the pi over 6 that is left, so tangent of 19 pi over 6 equals to tangent of pi over 6. What is tangent of pi over 6 on the unit circle, by the way, you guys? All right, so on the unit circle, you guys, notice a pi over 6, we have a square root of 3 divided by 2 and 1/2. Remember that tangent of theta is sine of theta over cosine of theta, or the same as y over x. What is y over x? Well, this is x, this is y. This is 1/2 divided by a square root of 3 divided by 2. What is that? Well, that's equals to 2 over 2 square root of 3, which you're left with 1 over a square root of 3. Well, remember that we want to rationalize the denominator every time that we have a radical in the denominator. So we're going to multiply by a square root of 3 and a square root of 3, the numerator denominator. In the denominator, square root of 3 times square root of 3 is 3, and the numerator is a square root of 3. That's why the answer is square root of 3 divided by 3. All right. All right, let's see. The answer, yes, Michael. Yes, Michael is asking about that because the period of sine and cosine is 2 pi. We subtract 2 pi for the sine or cosine, or 360. And for the tangent and cotangent, you guys, we're going to be subtracting pi because their period is only pi. Yeah, good question, Mike. Thank you. All right, so I don't know, you guys want to try an exercise on your own here, you guys? Well, you know what? Let me give you one for you guys. So try this exercise right here. Let's find the value of sine of 390. What is the value of sine of 390? So let me give you a minute for you to try. Let's see what we get. All right, let me see. I might have some answers already here. All right, pretty good, you guys. Very nice. Very good, very good, very good. All right, so what I'm going to do is, since 390 is more than 360, what I'm going to do is I'm going to subtract 360 here, right? And I'm going to left with 30 degrees. So sine of 390 is the same as sine of 30 degrees, which the sine of 30 degrees using the unit circle is equals to 1/2. Pretty good, you guys. You got 1/2. We're good to go. All right. Pretty good. So now let's continue. Let's continue. It says determine the signs of the trig function. Determine the signs. Notice I have already the signs there, but let me tell you how I got to that figure right here. Let me go over again. So basically what I do is I start with the 4 quadrants and I start using Z. Start with the 4 quadrant C. First is A. Second is S. And
Professor.
third, yes.
The doc viewer is just a little bit out of focus.
All right. No, thank you guys. Just thank you. Really appreciate that.
Much better. Thank you.
You're welcome. Again, this is to determine the signs of the trig functions, you guys. This is X and Y, quadrant 1, 2, 3, and 4. I use cast. What is that? Well, C stands for cosine. Here, these trig functions are the functions that are positive in each quadrant. In quadrant 4, the cosine is positive, and also the reciprocal of the cosine, which is secant. Cosine and secant, both of them are positive. Okay, so remember here, we have positive, negative. So cosine and secant are positive here. In quadrant 1, all of them are positive. All of them are positive. In quadrant 2, the sine, and cosecant, let me write it this way. The sine and cosecant are positive. The sine and cosecant are positive. The other ones are negative. T stands for, let me write it, this is negative and positive. For quadrant, we have negative and negative. The T stands for tangent. Tangent and cotangent in quadrant 4, both of them are positive. The other ones are negative. Ready? Okay, so let me go back here. And that's the same figure that I just did, but that's how I got this figure. So just remember those 4 words, and then you can find the sign for each trig in the corresponding quadrant. So let's try these 2 exercises. Probably I gave you the answer for some, but let's give it a try again. It says name the quadrant in which the angle theta lies. All right. So for A, if sine is positive, notice another way to let me go back to this chart here, or this signs right here. Another way to read these signs right here is, notice Y that corresponds to the sine. Quadrant 1 and 2 sine is positive, but quadrant 3 and 4 sine is negative. The same for the cosine. Cosine to the right of the y-axis, quadrant 1 and 4 is positive, but quadrant 2 and 3 is negative for the cosine. That's another way that you can also see it. All right. All right, so let's go back to this exercise. So it says name the quadrant in which the angle theta lies. Sine theta is positive. Well, sine, remember, is only positive in quadrant 1 and 2. But the cosine of theta is negative. Well, I know that quadrant 1, all of them are positive, right? So the only option is quadrant 2, right? All ready? Okay, so let's go over with B. The sign is negative. Okay, when the sign is negative? Well, the sign is negative either in quadrant 3 and 4. But also notice the tangent is negative. When is the tangent negative in quadrant 3 and 4? The only quadrant that tangent is negative, either in quadrant 3 and 4, that would be 4. So for B, the answer is 4. Ready? Okay, so let me see. I might have an extra. Okay, so let's try this one right here. Let's try this one together here. Let's find secant theta less than 0. Let's find the quadrant where secant of theta is less than 0 and sine of theta is greater than 0. Oops, might be. What would be the quadrant? Secant is negative, but the sign is positive, right? Well, okay, so I'll wait for you guys. Let me see what we're getting here. Okay. All right. All right. All right, so the sign of theta is positive. Well, it's either quadrant 1 or 2. All right. Okay, pretty good, you guys. Yeah, nice. Very good. Yes, since it's either 1 or 2, but the secant is negative, that has to be quadrant 2, you guys. All ready? Okay. Sounds good. Pretty good. So that would be quadrant 2. Perfect, you guys. All right. Okay. Very good. Let's continue. All right. So here I have identities, you guys, that we're gonna learn and we're gonna memorize these identities. Notice we have the quotient identities, which we probably have mentioned this already. Tangent theta is sine of theta over cosine of theta. But cotangent theta is equal to cosine of theta over sine of theta. Why is that? Because the tangent and cotangent are reciprocal of each other. On the right side, we have the Pythagorean identities. And these are sine square of theta plus cosine square of theta, that's equals to 1. And also we have 1 plus tangent square of theta equals to secant square of theta. And cotangent square of theta plus 1 equals to cosecant square of theta. Well, let me show you right here, you guys. If you guys remembered the first identity, sine square of theta plus cosine square of theta equals to 1. You guys can get the other two, and I'm gonna show you how to do so. So if you guys rewrite it and you divide by sine square of theta and sine square of theta and sine square of theta, what is sine square of theta divided by sine square of theta? That's equals to 1. What is cosine square of theta divided by sine square of theta? That is what? Cotangent square of theta. What is 1 over sine? That's equals to cosecant square of theta. So if you notice, that is the third identity that we got right here. And if now you start again with the with this identity, sine square of theta plus cosine square of theta equals to 1, but instead of dividing by sine square of theta, you divide by cosine square of theta each term, you get this identity, 1 plus tangent square of theta equals to secant square of theta. That's how we get these Pythagorean identities. All right. Okay. So my recommendation, you guys, all these identities, keep it together, write it down in one single, card or piece of paper where you guys having handy for you because we're going to be using these identities a lot. All right, so let's continue. All right, so there are another properties here that they're going to be also handy for us to solve some problems and even for graphing, even and odd properties of trig functions. All right, so just to remember that we went over even functions, and we know that an even function f of negative x equals to f of x, right? Or in other words, you guys, an even function is a function that is symmetric respect to the y-axis. You guys remember, right? That's an even function. An odd function, f of negative x equals to negative f of x, is symmetric respect to the origin. All right. Okay. So notice which functions are odd and which functions are even. Well, the only even functions, you guys, is the cosine. Cosine of negative theta is equals to cosine of theta, and the reciprocal of the cosine, which is the secant. Secant of negative theta is equals to secant of theta. The other four, you guys, are odd. Sine is odd. Sine of negative theta equals to negative sine of theta. The same as the cosecant, which is the reciprocal of the sine. The same as the tangent. Tangent is also odd. Tangent of negative theta equals to negative tangent of theta. And also the cotangent is also odd, an odd function, which is equals to negative cotangent of theta. All right. So let's look at this exercise right here. It says sine theta. All right, let me check here. Okay, good question. How come cosine is even already? How come cosine is even? Let me go over here, you guys. Let's see. Let me focus here. Right there. Oops. Oh, I see why I'm having this problem right here. Okay. I'm supposed to have only one single paper, and I think that is overlapping. Oh. All right, right there. Because why? The question is why cosine is even? All right. So we're gonna learn in the next. There are two ways. You guys have your calculator. Find cosine of negative 45 degrees and cosine of 45 degrees. And if you get the same answer, then we're proving it this way. There is then a picture here. I don't know if I can download it right here, but let me just give you an idea. This is what we're going to do next section right here. Well, the cosine happens to be, we know that the period is 2 pi, you guys. And we know that the amplitude is -1 and 1. So the cosine and we're going to do this next section, by the way. The cosine, let me get rid of, for now, let me get rid of this. The cosine, you guys look this way. This is y and this is x. So from here to here is 2 pi. That would be the period of the cosine. Notice the cosine, if we go over the unit circle, you guys, there's a little bit of next section, by the way. At 0, notice that the cosine is 1. At 90, the cosine is 0. At pi, the cosine is -1, which is right here. And at 3 pi divided by 2, the cosine is 0 again. And at 2 pi, the cosine is also equals to 1, which is right here. Why the cosine is even? Because remember that the domain of the cosine is from -infinity to a positive infinity. So all these values, if I keep going to the left, you guys, if this is pi and this is pi over 2, and I project this line on the left side, notice that at -pi over 2 and -pi over 2 is the same as 3 pi over 2 right here, you guys. Notice the cosine is 0, right? So it keeps going this way. At -pi, which is right here, the cosine is -1. And if you notice, I can continue this way, but notice here, the cosine is symmetric with respect to the y-axis. That's why it's even right here. Okay, that's the reason. Graphically, that's the reason. So again, we're gonna do this next section again, but this is the reason why the cosine is even, by the way. And the other one is odd. The other functions are odd. Well, cosine and secant are even. Well, that's graphically, that's the reason. But also, you, as I said, you can you can use your calculator and plug in, let's say, sine of 45 and find sine of -45. And you should get the same value, by the way. All right. Okay, perfect. So really, really good question. All right. So it says sine of theta. Let me see if anybody has a question here. Let me see here. All right, perfect. Thank you. All right, thank you, Barry, also for the picture right there. Perfect. Very nice. All right. So it says, let's try this exercise. Sine of theta and cosine of theta are given. Find the remaining trig functions. Notice the sine of theta is given, which is -3/5, and the cosine are also given, which is 4/5. -3/5 and 4/5. So we're gonna find the tangent, right? So we know that the tangent is the same as sine of theta over cosine of theta. So since we have the values of sine and cosine, notice that we plug in these values here. We're dividing two fractions, and we end up with -3/4. Since we know already the tangent, and we know that the cotangent is reciprocal of the tangent, okay? I'm not sure if I wrote the reciprocal functions, but I can write them right here, you guys. Let me see. I can write it right here. Reciprocal identities. Let me go right here. Let me focus right here. Yes. reciprocal identities. Remember that cosecant theta is equals to 1 over sine theta. Secant theta is equals to 1 over cosine theta. And cotangent theta is equals to 1 over tangent theta. So that will be the reciprocal identities. If you guys don't have it somewhere, you guys, please write it down. Those are the reciprocal identities. So notice also that if you go back here to this cosecant theta equals to 1 over sine theta, 1 over sine theta, this is the same as sine theta equals to 1 over cosecant theta, okay? This is also the same as sine theta equals to 1 over cosecant theta, and also applies for these other two down here, okay? So those are the reciprocal identities, by the way. I'm not sure if I wrote them down before, but please take a minute and write it down. All right, so let's continue with this problem right here. Notice that we found the tangent, and we can find the cotangent because the cotangent is the reciprocal of the tangent, which is how do I get -4 over 3, right? By reciprocating these two values, right? No problem at all. All right. Since we already have the sine and cosine, which is right here, the sine is -3 over 5, which is given already. I know that in order to find the cosecant, which is the reciprocal of the sine, all I gotta do is switch the order of these two values. So the cosecant will be -5 over 3. Again, the cosine is given, which is 4 over 5, which is right here. The reciprocal of the cosine would be secant, which is 5 over 4. Alrighty? Okay. So let's try. Let me just focus right here. Let me do something here, you guys. Okay. Right there. So notice the sine of theta is given -1/3, and the cosine is also given 2 square root 2 divided by 3. Let's find the other trig functions, please. Let me give you 1 minute for you to give it a try. All right, so let's see what we get. All right, so let me catch up with you guys. Tangent theta, again, is sine over cosine, which is -1/3 divided by 2 square root 2 divided by 3. And this is the same as -3 divided by 3 times 2 square root of 2. Notice this 3 with this 3 divide out, and you guys are left with -1 over 2 square root of 2. But notice you have to rationalize the denominator because you have a square root of 2. How do we do that? Well, let's multiply by square root of 2 and square root of 2, both of them, the numerator and denominator. So now you're left with negative square root 2. And square root 2 times square root 2 is 2. That will be 2 times 2. And this is equals to negative square root 2 over 4. So tangent of theta is negative square root 2 over 4. All right. All right, so I'm gonna find the cotangent now that I found the tangent, okay? So cotangent theta, that's the reciprocal of the tangent, which is -4 divided by square root 2. Again, I'm gonna rationalize the denominator. I'm gonna multiply by square root 2, both. And now what I have is -4 times the square root of 2 divided by 2, by the way. And if we simplify here, you guys, this equals to -2 times the square root of 2. Right there. That will be the cotangent. All right. So since the sine is given, sine of theta is equals to -1/3. I'm going to find the reciprocal of the sine, which is cosecant theta, and that becomes what? -3. Cosecant theta is -3. And cosine is also given, cosine of theta, which is 2 square root of 2 divided by 3. The secant, which is the reciprocal of the cosine, which is going to be 3 divided by 2 square root of 2. I'm going to rationalize the denominator again. And I'm going to be left with 3 square root of 2, 3 times square root of 2 divided by 4. All right, so let's see if we are getting something similar, you guys. All right, so everybody okay so far? We're good? All right, so seems that everybody's we're doing fine so far. All right, okay, so let's continue. All righty. Okay. Let's continue, and it says, example, find the exact value of each of the remaining trig functions. Notice what is given here. They're giving us the sine of theta, which is equals to 12/13. And also they're giving us the quadrant where theta is located. Theta is in quadrant 2. Okay. Theta is in quadrant 2. And the sine of theta is 12/13. Okay. So I know that sine of theta is equals to y/r, right? So based on the definition of the sine, I can find the value of y, which is 12. By the way, the value of y in quadrant 2 is positive, right? And r is equals to 30. So why do I need to know where theta is, in which quadrant? Because if they give us the quadrant, I know the signs of the functions on that corresponding quadrant. So I know the y is equals to 12, r is equals to 13, but I need to find the value of x first in order to find the rest of the trig functions, right? So in order to find the value of x, I'm going to use we can use the equation of the circle here, which is also the same as the Pythagorean theorem to find the value of x. If we write it this way, we solve for x. X is equals to plus minus the square root of r squared minus y squared. Notice we have the plus minus here. So which sign should we choose? Well, that's why they're telling us that theta is in quadrant 2. So the cosine or the x value in quadrant 2 or the cosine in quadrant 2 happens to be negative, right? Do you guys agree on that? Most likely you guys saying yes. And notice in quadrant 2, x is negative. So that's why we're choosing the negative sign. So now we do the math, we plug in the 13 and the 12. Happens to be that x is equal to negative square root of 25, and x happens to be negative 5, right? So now we have the three values that we need in order to find the rest, the other trig functions. So, all right. So sine is given. From the sine, I can find the cosecant, which is the reciprocal of the sine. Perfect. Notice I can find the sine now. I'm sorry, the cosine. So the cosine, by definition, is what? Is x over r, right? That would be negative 5 over 13. And then from there, I can find the secant, which is the reciprocal of the cosine. All right? And then I can find the tangent. Tangent by definition is y over x. But all right. Question is, how come? Oh yeah, well, we have a negative 12 over 5. Well, we can tell that since the x is negative, we get the negative from here, right? So yeah, this is obvious, you guys. No problem. Very good. And the cotangent is the reciprocal of the tangent, so the cotangent is the reciprocal of the tangent, which is negative 5 over 12. So I think that let me know if you guys have any questions at all. If not, let's try B here. Let's try B right here. Let's try tangent equals to negative 1/3. And the sign is positive, by the way. Notice, sign is positive. So it might help to find the quadrant, because from there we can tell what would be the sign of the other trig functions, by the way. Tangent is negative, but sine is positive. So find the quadrant, right? Okay. Yeah, you're correct, Leila. It's quadrant 2. Very good. Quadrant 2. Yes, we're working in quadrant 2, by the way. Okay. Quadrant 2. So you know the signs right there, and remember that by definition, well, let me give you another minute for you to try it, and then we'll try it together. Let's just remember, I was gonna say by definition, tangent of theta. Well, this should be tangent of theta, by the way. I'm missing the theta right there. Tangent theta is sine over cosine, or y over x. Y over x. Sine over cosine. So y is equals to negative 1. And x is equals to 3. But since we want to find the rest of the trig functions, we need the value of r, you guys. We need the value of r. So, excuse me, to find the value of r, we know that r squared is equals to x squared plus y squared. So r is equals to plus minus the square root of negative 1 squared plus 3 squared, which is r. Since this is the radius is never negative, you guys. It's always positive. And that would be 1 plus 9, and r would be a square root of 10, by the way. R would be a square root of 10. And with this value of r, you can find the rest of you can find the rest of the trig functions, right? So for example, sine of theta, all right? Sine of theta is what? Y over r, and that's equals to -1 over square root of 10. But we had to multiply, right? We had to rationalize the denominator, by the way. So let's multiply by square root of 10, square root 10. And what do we get here? Negative square root 10 over 10. That would be the sine of theta. All right. All right. So, excuse me. Let's move on here, you guys. Since that we know how to find. Okay. All right. So good question. Since sine of theta, since sine is greater than 0, which is positive, wouldn't y equals to 1 and x equals to -3? Good question. Good question. Okay. So notice, oh, that's a good question. And the question is, let me just repeat it. Since sine is positive, wouldn't y equals to 1 and x equals to -3? That is correct, by the way. That is correct, by the way. Since we're talking about quadrant 2 here, you guys, notice that the sign in quadrant 2 is positive. Let me write it this way. And x is negative here. Yeah, I agree with that, definitely. Tom, I agree with that, definitely. Yes. Even though, you guys, even though, yeah, but no, definitely, I agree with that. I was gonna say something else, but I agree with Tom right here. Yes, y is positive, and the x which corresponds to the cosine in quadrant 2 is negative. So this should be the right signs, you guys. All right, can you guys make that correction? All right, thank you, Tom. Pretty good. All right, so I'm going to let you finish that problem later, and I also have C down here. You guys can do that one a little bit later also. All right, so let's continue right here. It says use even odd properties. Use even odd properties to find the exact values of each expression. Do not use calculator. All right. So notice, let's look into A. It says we're going to find the sine of -60. Well, notice sine is an odd function, right? So sine of -60, I can also write it as negative sine of 60. What is sine of 60, you guys? What is sine of 60? Look at your unit circle, the one that you guys did last time. Sine of 60 is square root of 3 over 2, by the way, but you have the sign in front of them. In front of that, that would be negative square root of 3 divided by 2. Yes, so yes, Tom, yes, square root of 3 divided by 2, you're right, and remember that because of the negative sign that is, that would be, the answer would be negative square root of 3 divided by 2, right? All right, so the same for B, you guys. Notice for B, we have the tangent of negative pi over 4. Again, tangent is odd. Tangent of negative pi over 4 is the same as negative tangent of pi over 4, by the way. What is tangent of pi over 4, by the way? Happens that tangent of pi over 4 is equals to 1, you guys. You guys have the unit circle right there with you guys? Let me see. I have it right here. The tangent of pi over 4 right here, you guys, the tangent here is 1, by the way. Here, tangent of pi over 6 here is square root of 3. And I think that we did this square root of 3 divided by 3. And for pi divided by 3, the tangent, and let me, tangent here is square root of 3. I mean, you can find it by dividing the sine over the cosine. That's how we get these values, okay? That's how we get these values. Let me just make sure, you guys. Okay. So this is how we find these values, and you can find it all over the unit circle, by the way. All right, just to let you know. All right. So the same for the cosecant. Let me just focus right here. It's out of focus. The same for the cosecant, you guys. Cosecant of negative pi over 4, which is an odd function, by the way. Cosecant of negative pi over 4 is the same as negative cosecant of pi over 4. So notice here, I don't know myself what's in, I have not memorized what cosecant of pi over 4 is, but notice I'm using the reciprocal of the cosecant, which is 1 over sine, right? So, but I know what sine over pi over 4 is from the unit circle. So it's negative 1 over the sine of pi over 4, and sine of pi over 4 is square root 2 over 2. Now, this is equals to negative 1 over square root 2 over 2, which is the same as negative 2 divided by square root 2. And if we rationalize, you guys, if we multiply by the square root 2 in each side, that would be negative 2 square root 2 divided by 2. And at the end, that would be negative square root 2. That would be C. Okay, you guys. So again, we're using the reciprocals here. Ready? Okay. No problem, Tom. And is that clear for C, you guys? So when a function that you guys are not familiar with, and use the reciprocal, you know, sometimes that really helps. So what would be the answer for D? Let's do D really quick. Secant of negative 60. What is secant of negative 60? Secant of negative 60, all right? So, okay. Oops, excuse me. All right, Layla, pretty good. Let's find secant of negative 60. Well, is a secant an even function or odd function? Can we get secant from the unit circle? We can use the reciprocal of the secant. What is the reciprocal of the secant? Well, so we can use all those tricks, you guys. Okay, I'm just waiting a little bit more for you to find there. Yes. the secant is the reciprocal of the cosine, right? So it is even, by the way, you guys. It is even, okay? It is even. Since the cosine is even, the secant is even. So secant of negative 60 is the same as secant of 60 degrees, by the way. But I don't know, out of top of my head, I don't know what secant of 60 is. So I can use the reciprocal of the secant, which is the cosine. So this is the same as 1 over cosine of 60. All right. So what is cosine of 60? It is 1/2. All right. So 1 divided by 1/2 is what? That happens to be 2, you guys. That should be the answer. That should be the answer. All right. So, all right. So seems that we got that. And I think that we're done with 6.3, you guys. Yeah, perfect. We're done with 6.3. You guys don't have any questions. Let's take a 10-minute break and we'll continue in 10 minutes. Sounds good? All right, so let's take a break, have a glass of water, and we'll be back in 10 minutes. All right. All right, so let's continue. Let's continue. Let's start at 6.4. This is graphs of the sine and cosine functions. Objectives, graph functions of the form y equals to a sine of omega x using key points, and graph functions of the form y equals to a cosine omega x also using key points. All right, so we're gonna start with the graph of the sine function, y equals to sine of x. So the sine of the function sine of x, we're gonna get it from the unit circle, very, very similar as we got the cosine of x in the last section. So here we're gonna be able to see why the domain is from negative infinity to positive infinity, and why the range is also from -1 to 1, by the way. All right, so let's give it a try. Let's go over the unit circle. Notice at 0, the sine is 0. So we start right here. And at pi over 2, the sine, notice that is 1. So at pi over 2, the sine is 1. At pi, notice that the sine is 0. And at 3 pi over 2, the sine is -1. The sine is -1 right here. And at 2 pi, the sine happens to be 0. We go back again at 0 right here. If we connect these points, that's how the sine waveform looks like. But remember, this is just one period. One period is 2 pi. So from here to here is one period. Or also, well, I'm gonna use also, it's also one cycle, by the way. One period. Well, the period of the sine is 2 pi, and one period or one cycle, well, is, I'm gonna be using this term right now. Here, one period is equals 2 pi, and one cycle is also 2 pi. But remember that it keeps repeating. It keeps going all over. You know, the domain is all over. We keep going as many periods. We can graph it as many periods we want to the right and also to the left. Notice if we continue to the left, you guys, if we go continue to the left, that's why the sign is odd. Notice if we continue, I'm gonna continue here. Let's say here is negative pi over 2. And negative pi over 2, this is equals to -1. So notice the sign is odd because it's symmetric with respect to the origin. That's why the sign is odd. All right, so this is the sign, by the way. Okay, so notice, let me go back here. Notice the amplitude here, when we write y equals to sine of x, here we got a 1 implied here. That is the amplitude. Okay, this is known as the amplitude. The amplitude is 1. Okay, which, and let's go over this definition right here. It says graph of the functions of the form y equals to a sine of omega x, and y equals to a cosine of omega x. All right. So let me start right here. It says y equals to a sine omega x and y equals to a cosine omega x, where notice the absolute value of a, this value right here, is known as the amplitude. Omega is a horizontal compression or stretch, depending on the value of omega. And if we want to find the period, you guys, because later on we're going to be changing the value of omega here, and also changing the value of a. For going back to this, the basic sine function, the amplitude is 1, and also omega happens to be 1. So when we start changing those values, in order to find the period, we're going to be using this formula. We're going to be using t equals to 2 pi over omega. Why 2 pi? The 2 pi is of the cycle of the sine, which is 2 pi, divided by the value of omega. All right, so let's continue. So notice here, let's try graphing here a here. It says graph using key points. Y equals to a sine of 4x. All right, so this value of 4x, the value that is within parentheses, is also known as the argument. So let's go step by step. Let's find the amplitude. The amplitude is the absolute value of 2, which is 2. All right, so that's the amplitude. Let's find the period. Let's find the period. T is equals to 2 pi over omega. And this is 2 pi over 4. And this is equals to pi over 2. That would be the period. So this 4 is compressing the sine, the basic sine. This 4 is compressing. Now the period is pi over 2, and one cycle is going to be from 0 to pi over 2. All right, so let me go back to the basic function, because I want to explain how to find the key points. And if you notice, in order to graph the basic sine here, I found 0, pi over 2, pi, 3 pi over 2, and 2 pi. And if you notice, there are 4 partitions, or intervals, 1, 2, 3, and 4. These values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, are known as key points. How do I find the key points? Well, in order to find the key points, what I'm going to do is, first thing, I'm going to find the period. All right. And after I find the period, in order to find the increment that I'm going to be adding to the, in order to find the key points, I'm going to divide the period by 4. Why by 4? Because there are 4 parts, 1, 2, 3, 4. That's how I'm going to be finding these values, these corresponding values. So I'm going to use what I said right now for the next exercise. So I know what the period is. So the sine wave that we're going to graph is going to go from 0 to pi over 2. Now let's find the key point. To find the key points, first thing that I'm going to do is I'm going to find the key points increase. And that is equals, how do we find that the increase? That's equals to the period divided by 4, which is equals to pi divided by 2 by 4. And that's equals to pi over 8. This is the value that I'm going to be using in order to find the key points. So let me just do one more thing, you guys. We know that a sine or cosine, to find, let me write it, one cycle, you guys. Forget about this, and let me write it right here. So one cycle is the argument. To find one cycle, you guys, this is the argument greater or equal than 0, but less or equal than 2 pi. Why is that? Because we know that the sine goes from 0 to 2 pi. What is the argument? The argument is 4x, less than 2 pi, greater or equal than 0. So we're going to solve for x here. And if we solve for x, you guys, if we divide by 4, we divide by 4, and we divide by 4, x happens to be pi divided by 2 greater or equal than 0. So this is one cycle, you guys. The waveform that we're going to grab goes from 0 to pi over 2. That's one cycle. Now, let's find the key points. What are the key points again? These values right here. That's going to help us to graph. So this is how we find the key points. We found the key points increase right here. So we know that we're going to start at 0. The cycle tells me where to start. We start at 0. So the first key point is 0. The next value, to find the next value, I'm going to add where we start plus pi over 8. So that would be 0 plus pi over 8, which is pi over 8. That would be another key value, pi over 8. To get the next key value is going to be pi over 8 plus pi over 8. That's equals to 2 pi over 8. All right, my recommendation, you guys, do not simplify right here. Keep it with the same denominator. And I'm gonna tell you why, because if you keep it with the same denominator, when we graph, it's easier to, especially with fractions, to have the same denominator. The next key value is gonna be 2 pi over 8 plus pi over 8. That's equals to 3 pi over 8. Notice we got 1, 2, 3. We need one more because we have 4 intervals. So far we got 3. 1, 2, 3. We need one more, you guys. So that would be 3 pi over 8 plus pi over 8. That's equals to 4 pi over 8. That would be the fourth. But notice, if you simplify 4 pi over 8 is the same as pi over 2, by the way. But when graphing, it's better to keep the same denominator, because if you start simplifying here, your denominators are different. And when you start graphing, it might get a little bit confusing here. Notice now I can start graphing right now. So let me go back to this basic function again to understand the amplitude. So here, for this sine wave, the amplitude is the absolute value of 1, which is 1. So this amplitude refers to, that means that I'm gonna go from 0, I'm gonna go 1 up and 1 down. So if we go back to the graph that we're gonna graph, since the amplitude here is 2, that means that I'm gonna go up 2 and 2 down. So the range is gonna be from -2 to 2, in other words. All right, so let's give it a try. So let's try it right here. Right there. All right, so I'm gonna go 2 down and 2 up. -2, -1, 1, and 2. Now I'm gonna start at 0 and I'm gonna go all the way to 4 pi over 8, which is the same as pi over 2. Okay, so let's say that here, you guys, this is pi over 2 or 4 pi over 8. Let me write it with 8s here. And let's say that here you guys just to for explanation here, this is pi over 2, this is pi right here, which is the same as 8 pi over 8. This is pi over 2, right? If I had from 0 to pi is 1 whole, right? So I can divide from here to here in 8 parts, right? So, but I only need pi over 2, which is from here to here. So I'm going to divide from 0 to pi over 2 into only 4 parts. And I start, this is 0. And this is pi over 8. This is 2 pi over 8. This is 3 pi over 8. And this is 4 pi over 8, right? That's all I need. If I wanted to just graph one cycle, this is what I need. So here, I'm going to project these lines right here as a reference, and also here at 2 as a reference. And then from here now, I can start plotting the points where I'm going to be graphing here. Since this is the sine, you guys, I know that the sine is symmetric with respect to the origin. So I'm going to start at 0 here. At pi over 8, I know that the sine goes up. At 2 pi over 8, the sine goes back to 0. Pi over 8 goes up 2. At 2 pi over 8 goes back to 0. At 3 pi over 8 goes down to -2. And at 4 pi over 8, it goes back to 0. And if you connect these points right here, you guys, that would be the corresponding waveform to 2 sine of 4x. If we wanted to, this is just one cycle. If we wanted to continue 2 cycles, then we would divide this part also in 4 parts. It will continue writing, and then we continue the waveforms. That would be for 2 cycles. This is just one single cycle here. All right. So let me see if anybody of you have a question here. Let's see. Okay. Is that clear, you guys? How we found the key points here. So that's the same technique that we're going to be using here, you guys. Okay. So I'm going to skip B here but we're gonna go and try cosine. Well, y equals to cosine of x. I did it last lecture. I mean, not last lecture, last section. And probably you guys remember what I did there. But you know what? Let me try D. I'm gonna try D. I'm gonna try D. And you know what? I'm gonna add one value here. Can you guys add a +1 there, please? All right, so let's try D together. It is y equals to 2 cosine of -3 pi divided by 2, x plus 1, okay? All right, okay. So notice we have cosine of negative 3 pi divided by 2x. But you know, we know that the cosine is an even function, right? So instead of using that negative in that argument, I'm gonna change it to positive because it is gonna be the same, right? So since, I'm gonna write this, since cosine theta is even, then y equals to 2 cosine of 3 pi over 2x plus 1, right? So I don't have to worry about that negative sign anymore because the cosine is even, all right? So we're gonna do the same steps as we did before. Let's start with the amplitude. Amplitude is the absolute value of 2, which is 2. All right. Then let's find the period. All right. So the period which we're going to be using t, since we're talking about the cosine, again, the period is 2 pi over omega. And notice here, 2 pi, omega is 3 pi over 2, by the way, is 3 pi over 2. All right. So this is the same as what? At 4 pi over 3 pi. Pi divided by pi is 1, and the period is 4/3. 4/3. That's what the period is. So let's find the increment. Let's find, by the way, these are radians, okay? These are radians for 4/3, which by the way, this is this value here, 3 pi over 2, is compressing the cosine. It is compressing the cosine big time, okay? So let's find the key point increase. Remember, in order to find the key point increase, this is the same as t over 4. Why over 4? Because remember, we're finding, we are dividing the period in 4 intervals, 4 parts. So this is the same as 4/3 divided by 4, which is what? 4 divided by 12, which is the same as what? 1/3. So the key point increase is 1/3. Now, I'm gonna find one cycle, one cycle. cycle. Remember, in order to find one cycle, what you do is you get the argument and you make a less than or equal than 2 pi and greater or equal than 0. So what is the argument? The argument is 3 pi divided by 2x less than or equal than 2 pi greater or equal than 0. So we're solving for x here in the middle. We're solving for x. So first thing that we're going to do, let's get rid of these 2 by multiplying by 2 the 3 parts here. All right, multiply by 2. If you multiply by 2 times 0, that would be 0 right here. You're left with 3 pi x less than 4 pi, right? Here we multiply by 2. Multiply by 2. All right, and then to solve for x, I'm gonna divide by 3 pi in each part. 3 pi, 3 pi, and 3 pi. So now I'm left with x less than or equal than 4/3 and greater or equal than 0. All right, so the cycle, you guys, is gonna go from 0 to 4 pi over 3. All right, so let's find the key points. Let's find the key points. Key points. Key points. The cycle, let us know where we're gonna start. We're gonna start at 0. The next, notice, what is the key point increase? The key point increase is 1/3. 1/3. So the next key point, that will be 0 plus 1/3, which is 1/3. The next would be 1/3 plus 1/3, which is equals to 2 what? 2/3. The next is gonna be 2/3 plus 1/3, which is what? 3/3. The next is gonna be 3/3 plus 1/3, which is 4/3. And this is gonna be the last key point. Notice, how do we know what would be the last? Because this key point should be also the end of the cycle. These two are the same. That's another way to know where you guys stop. So these are the key points. These are the key points that we're gonna be using to graph this function right here. Now here we're ready to graph, you guys. Okay, let me go back here. All right, so let me know. Okay, so you have any questions? All right, so let me wait 1 minute for you to catch up, and if you have any questions, please let me know. All right, okay. So let's give it a try here. All right, so notice also that here +1, this is a vertical shift, you guys. So this graph is gonna go up 1 unit right here. Okay. So first thing that I'm gonna do is I'm going to scale the x-axis and write the key points. Notice 4/3 is more than 1, it's 1 and 1/3, right? So if this is 1, and let's say this is 2, you guys, we're gonna partition the whole into thirds. So let's say that I partition each whole into thirds. So this is 1/3, 2/3, 3/3 right here, 4/3, 5/3, and 6/3, which is 2, right? So the graph is gonna go from 0 to 4/3 right here. That's where we're gonna stop right here. All right. Now, this is what I'm gonna do next. Next, I'm gonna take care of the vertical shift right here, which is this +1. Okay. So what I'm gonna do is, instead of starting at 0 right here at the origin, I'm gonna go up 1. So notice also the amplitude. The amplitude is 2 here, right? All right. So this is what I'm gonna do. I'm gonna scale here, and I'm gonna go 1, 2, 3, and also I'm gonna go down here 1 and 2. So again, first thing that I'm gonna do is I'm gonna take care of the vertical shift, which is 1. At 1, I'm gonna draw this line right here where this is gonna be my new reference here to start graphing. I'm gonna start graphing at this line right here. Okay, I'm just gonna move these values here. The 1/3 is gonna be right here. The 2/3 is gonna be right here. The 3/3 is gonna be right here, and the 4/3 is gonna be right there. Ready? And now that I move up 1, I'm gonna take care of the amplitude. From this line, I'm gonna take care of the amplitude. From this line, the amplitude is 2, you guys. So from this line right here, I'm gonna go up 2 and down 2, all right? And I'm gonna do this. I'll go 1 and 2. I wanna draw a line also here as a guide for me. And from this line, I'm gonna go down 2, 1 and 2, right here. This line and this line are gonna be my guides to draw the cosine. All right? Okay, so we're ready to start drawing the cosine. Now, if we go back to the unit circle, notice that at 0, cosine starts at 1. Okay, at 0, cosine starts at 1. So I'm gonna start right here. Alrighty? Then, since these are the four key points right here, I know that it starts at 1 and it goes back to 0, the next value. So I'm gonna go back to 0 at 1/3 right here. I'm sorry, for this case, I'm gonna go back to 1, which is the vertical shift, by the way. I'm gonna go back to 1. At 2/3, let me write it right here. By the way, this is 0 and this is -1. At 2/3, I'm gonna go to -1, which is right here. At 3/3, which is 1, I'm gonna go back to 1. And at 4/3, which that's where the cycle ends, I'm gonna go all the way to 3. Okay? So again, let me go back here. We know that based on the unit circle, for the basic function of the cosine, at 0 starts at 1. So for this specific function here, at this reference line, we're gonna start at 3. For 1/3, we're gonna go back to 1. For 2/3, we're gonna go down to -1. Excuse me. For 3/3, we're gonna go back to 1. And for 4/3, we're gonna go up to 3. And if we connect these points right here, this is how it looks. That is the function sine. Excuse me. Y equals to 2 cosine of 3 pi divided by 2 times x plus 1. All right, let me know if you have any questions. So let me repeat what I did again. Okay, so again, given the function, I start by finding the amplitude. I find the period. I find the key point increase. And also I find one cycle. It tells me where it starts, where it ends. From there, I find the key points. Now that I found the key points, I start my graph and I scaled it. I draw the key points here. After I draw the key points, first thing that I'm gonna take, if I have a vertical shift, you guys take care of the vertical shift at this moment. At this moment, take care of the vertical shift. After you guys take care of the vertical shift, which is this line right here, now take care of the amplitude. The amplitude, you're gonna go up 2 and 2 down. And take this vertical shift as a reference to start graphing. And this is how we get the graph of this function. And if you guys have any questions, please feel free to let me know. All right. Okay. So with this function, we're done with 6.4. Okay. And I'm gonna let you try the other functions for you. And we're gonna start. You know what? This is 6.4. And let me jump into 6.6. We're gonna skip 6.5 for now. And the reason, let me show you why. Why is that? Because now that we know how to graph sine and cosines, by the way, 6.6, which is right here, is a continuation, by the way, of 6.4. But what's the difference between one and the other? Well, 6.6 includes phase shift. What is a phase shift? Now, it's a horizontal shift now. It says phase shift, sinusoidal. Sinusoidal means sine and cosine, by the way. When you guys hear sinusoidal functions, we're referring to the sine and cosine. Sinusoidal curve fitting. The objective is graph sinusoidal functions of the form y equals to a sine of, notice, y equals to a sine of omega x minus phi plus b. Notice that now we're including a horizontal shift and also a vertical shift. And by the way, this is also, and you guys can add also, this is also y equals to a cosine of wx minus phi plus b. Also, we're including both. And notice what it says. For the graphs of y equals to a sine of omega x minus phi plus k or b, I'm using k and b here. You know what? Let me change it to b here. B. Be consistent, by the way. Notice for this kind of graphs, now that we are including a phase shift, a horizontal phase shift now, notice the amplitude is the same. The period is found the same way, but now notice the phase shift is found by dividing phi, which is this value, by omega. That's how we find the phase shift, okay? So here, we're gonna try this graph together. We're gonna try this graph together. Y equals to 2 plus 2 cosine of 3x minus pi over 2. Notice, all I did, I rewrote this function in this form as y equals to 2 cosine of 3 times x minus pi over 2 plus 2. This is the vertical shift, you guys. And this is the horizontal shift. And this is the amplitude. So again, we're gonna use the same steps as we did in 6.4. That's why I'm skipping 6.5 right now. By the way, 6.5, we're gonna learn how to graph the tangent and cotangent, secant and cosecant, by the way. So let's try this function right here. Again, same steps as before. Let's find the amplitude. Amplitude, that's the absolute value of 2, which is 2. Let's find the period. The period is 2 pi over w, which is 2 pi. What is w, guys? W is the 3 here. That's the 3 right there. So that's the period right here. Now that we have the period, let's find the key point increase. The key point increase. Remember, in order to find the key point increase, that's t divided by 4, which is going to be 2 pi over 3 divided by 4, which is the same as 2 pi over 12, and this is the same as pi over 6. That would be the key point increase, pi over 6. All right, so we have the period, we have the amplitude, and we have the key point increase, which is pi over 6. Now, let's find one cycle. Let's find out where we're gonna start and where that cycle is gonna start and when that cycle is gonna end. One cycle. Again, get the argument. By the way, this is the argument, okay? This is the argument, argument. Get the argument, make it less than or equal than 2 pi, greater or equal than 0. Why less than or equal than 2 pi greater than 0? Because remember, the cosine, the period of the cosine, or the cycle of the cosine goes from 0 to 2 pi. So next, we're gonna include the argument here, which is 3x minus pi over 2. We're gonna make it less than or equal than 2 pi and make it greater or equal than 0. And we're gonna solve for x here, you guys. We're gonna solve for x here. Ready? Okay, so let's give it a try. Let's solve for x here. So first thing that we're gonna do is we're gonna add pi over 2 and pi over 2 and pi over 2. All right? If we do that, we're left with, let me use this color here, 3x less than or equal, what is 2 pi plus pi over 2, you guys? Well, rewrite 2 pi as with the denominator of 2. 2 pi over 2 is the same as 4 pi over 2. So 4 pi over 2, let me do it right here, notice. 2 pi plus pi over 2. Rewrite the 2 pi with the numerator 2, that would be 4 pi over 2 plus pi over 2. This is the same as what? 5 pi over 2. So this is 5 pi over 2, greater or equal than pi over 2. Now divide by 3. Let's divide by 3, let's divide by 3, and let's divide by 3. Now here we have x less than or equal than, let me rewrite it right here, you guys. Here would be 5 pi over 6 greater or equal than pi over 6. This is the period. I'm sorry, this is one cycle, you guys. Right there. Okay. So when we find one cycle, we're gonna start at pi over 6. And we're gonna end at 5 pi over 6. Okay. A value that we didn't find that we can find, you know what, let's find the phase shift right here. I'm gonna find it right here, okay? Phase shift. All right, so be careful when you guys wanna find the phase shift, because notice that here, the what? Yes, I can hear you. Questions? Oh, okay. For the phase shift, you guys, notice that here we have a negative sign, which corresponds to the negative sign that we also have here, okay? So let's be careful when finding the phase shift, right? So the phase shift, let me go back here, is phi divided by omega, right? So the phase shift here is, what is 5? That's pi over 2, right? Divided by omega, what is omega? 3, right? So the phase shift is pi divided by 6. That's the phase shift, by the way. All right, that's how we find the phase shift. All right, so let's go back to the one cycle here that we found. So now that we found the one cycle, we know where we're gonna start, we know where we're gonna end. Let's find the key points. Let's find the key points. Key points. All right, the key points. All right, so we know that we're gonna start at pi over 6. So that's the first value, pi over 6. Notice, let's go back here. What are the increments? The key point increments is pi over 6. So the second key point is gonna be, we start at pi over 6. It's gonna be pi over 6, which is this value, plus the increment, which happens to be pi over 6 also, pi plus pi over 6, which is 2 pi over 6. The next key point is 2 pi over 6 plus pi over 6, which happens to be 3 pi over 6. The next key point is going to be 3 pi over 6 plus pi over 6. That's 4 pi over 6. We got 1, 2, 3. We need one more. The next key point is 4 pi over 6 plus pi over 6. That's equals to 5 pi over 6. So we got all the key points that we need. Notice. Those are the key points that we need, you guys. So again, as I said before, where do we stop? This key point should be the same as this end point of the cycle. That's where we know where to stop. All right, so we got the key points. So we're ready to graph now, you guys. We're ready to graph now. Okay, so let's give it a try. Let's give it a try. All right, so keep the key points here and let's give it a try here. Let's graph it. Let me draw something here and I'm gonna focus here. All right. Right there. Okay, so let's scale the x-axis here. And notice, let me go back and let's check let me put the key points together here. So remember that we're gonna start at pi over 6, and we're going to end at 5 pi over 6. So notice it's less, this graph is less than pi, by the way. All right. So let's say that here you guys decide to be pi, which is the same as 6 pi over 6, by the way. And from 0 to pi, you divide in 6 parts, and let's do that. All right, 1, 2, 3, 4, 5, 6. So here is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 5 pi over 6. So our graph is gonna go from this line right here all the way to 5 pi over 6. All right, so let me move this paper here, and all right, so that's how it's gonna start. This is where we're gonna end. Okay. All right. So now what I'm gonna do is I'm gonna take care of the vertical shift. Notice the vertical shift was what? The vertical shift was 2, by the way. So what I'm gonna do is I'm gonna go up 2. 1, 2, 3, 4. So I'm gonna go up to 1, 2, 3, and 4 at 2. I'm gonna draw this vertical shape. That's the first thing that I'm gonna do. Two, all right? And I'm gonna bring up the points that I'm gonna be needing in order to graph. So I'm gonna bring up this point right here, this point right here, this point right here, this point right here, and this point right there, okay? And now I'm gonna take care of the amplitude, you guys. Notice the amplitude happens to be also 2. So from this point right here, now I'm gonna go up 2 and 2 down. So I'm gonna draw my new reference lines also at 4. I wanna draw this reference line right here, and at 0, well, at 0 is already here because 2 down is the x-axis, by the way. And now that I have my reference lines, I'm ready to start graphing now. Okay. All right. Since this is the cosine again. So at this point, we know that the cosine goes up here. So I'm gonna start here. At the next point right here, I'm gonna go up 4. At 2 pi over 6, I'm gonna go down to 2. At 3 pi over 6, I'm gonna go down to 0. At 4 pi over 6, I'm gonna go up to 2. And at 5 pi over 6, I'm gonna go up to 4. And if I connect these points right here, that's what we have. Notice it is shifted pi over 6, and it ends at 5 pi over 6. So notice that's why I'm covering right now 6.6 because that basically that's a continuation of 6.4. So we have the knowledge of 6.4. We're using the knowledge of 6.4 to cover 6.6. Let me know if you have any questions on 6.6. Basically, 6.6 that's all it takes, you guys. That's it for 6.6. So I included a couple of more exercises in 6.6 in your handout, printout that you guys have, and you can try that later. Give it a try and see what you guys get, and if you have any questions, please let me know. So this is it for 6.6. We're gonna go back to 6.5 now, you guys. Unless anybody of you have any questions, please let me know. All right, so let me put 6.6 away and let me get 6.5. We're moving pretty good today, you guys, pretty good. All right, so 6.5. I have it right here with me. And in 6.5, we're gonna cover the other functions here. Let me, it says graphs of the tangent, cotangent, cosecant, and secant functions. Notice the objectives, graph functions of the form y equals to a tangent wx, omega x is not w, omega x plus b, and y equals to a cotangent omega x plus b. Next objective is graph of functions of the form y equals to a cosecant omega x plus b, and y equals to a secant omega x plus b. So we're gonna graph those functions now. I want you to remember in 6.3 that we covered the domain and the range of each. All right, so we're gonna start graphing the tangent function. And if you guys remember going back to the domain of the tangent function, we said that the domain, I have the unit circle here, right? So the domain is all other values except the odd multiples of pi over 2. So the tangent does not exist at pi over 2 or at 3 pi over 2, which is the same as negative pi over 2, by the way, okay? 3 pi over 2 is the same as negative pi over 2. So in order to graph the tangent function, you guys, I kind of draw part of the unit circle right here, and here, these are the values that correspond to the tangent for pi over 6, pi over 4, pi over 3. And notice I'm also going down here. This is negative pi over 6, negative pi over 4, negative pi over 3, and this would be the corresponding also values of the tangent function, right? So notice here, I have a table right here. If I plug in x, if I make x equals to pi over 3, I can write the corresponding value of the tangent here, and based on the unit circle right here, pi over 3 is the same as the square root of 3. Pi over 4, notice, and I'm gonna write this in red right here, is 1. At pi over 6 is square root of 3 divided by 3. At 0 is 0. At negative pi over 6 is negative square root of 3 divided by 3. At negative pi over 4 is negative 1. And a negative pi over 3 is negative pi over 3. So if we plot these points right here, we're gonna be able to get the graph that corresponds to this function tangent of x, and that's what we're gonna do next. So remember that tangent does not exist at pi over 2 and negative pi over 2. So the graph of the tangent function goes from negative pi over 2 to pi over 2. So let's say that here and here I got pi over 2, and here I have negative pi over 2. Okay. And here, since tangent does not exist at those 2 points, what I'm going to do is I'm going to draw imaginary lines right here at pi over 2 and negative pi over 2. All right. So notice the values that I have in red in the table. I have that at pi over 4, which is 1, right? So where is pi over 4? Well, pi over 4 is right here. Pi over 4. Also notice that I also have a 0, right? Which is right here. 0 is right here. And another value is a negative pi over 4, right? Which is negative 1. All right. So I'm going to draw the negative pi over 4. Negative pi over 4. All right. So notice when I write those values that I have in red, notice that I have the 4 intervals, the 4 partition. Notice 1, 2, 3, and 4, right? So in order to graph the tangent, we only need these values. Yes, one of you is making that noise with probably your mic, that we can hear you, just in case. Everybody can hear you guys, okay? Just to let you know. All right, thank you. All right, again, those values in red, that's all the values that we need in order to graph the tangent. Okay, and we're gonna plot these points right here. Notice, at pi over 4 is 1, right? This is 1, and this is negative 1, okay? So at pi over 4 is 1, I'm gonna plot it right here. And at negative pi over 4 is negative 1, is right here. And also we got 0 equals to 0, right? Which is right here. So now I'm gonna connect these points here. The tangent function looks this way. Just connect these points right here and connect these points right here. So by the way, pi over 2 and negative pi over 2, these two are two vertical asymptotes, by the way. So it goes through this point, it gets closer and closer to pi over 2 and negative pi over 2, but never touch these two values. And in that, this is, let me focus here, go back here, right there. This is how the tangent function looks like, you guys. All right, so let me know if you have any questions. So that's the tangent function. So the cotangent function, we get it, the same idea here, same idea. So let's go over the cotangent function really quick. So for the cotangent function, remember the cotangent function is undefined at 0 and pi now. So the values of the cotangent function, I have them in blue right here, okay? So let's fill out this table right here with these values right here. So at pi over 6, I have square root of 3. At pi over 4 is 1. I'm going to do it in red. At pi over 3 is square root of 3 over 3. Notice at pi over 2, this should be pi over 2, by the way. At pi over 2, here we have 0,1. Okay. So remember, what is the value of the cotangent? Well, the tangent here yes.
It's out of focus.
Oh,
Again.
sorry about that.
No worries.
I'll let me just, excuse me. Notice at pi over 2, the cotangent is equals to 0. Remember, cotangent by definition is equals to cosine over sine, right? That would be 0 over 1, which is 0. Is that clear, everybody? At pi over 2 is 0. At 2 pi over 3 is negative square root of 3 divided by 3. At 3 pi over 4 is negative 1. Excuse me.
Professor, it's still out of focus.
Oh, I'm sorry about that.
Okay.
Let me finish right now, and I'll fix it right now. Let me just plug in these values right here really quick, and I'll fix it right now. Okay. Huh. Let me, right there. Good. Notice, again, I got those values from the unit circle, and same idea as before for the tangent. We're gonna use the pairs in red to graph it, but notice, remember, now we're gonna go from 0 to pi now. But remember, at 0, it is undefined, and also at pi. So the graph of the cotangent if this is 0 and this is pi, at pi, this is a vertical asymptote. And also at 0, by the way, the y-axis is a vertical asymptote. And notice the regions that we care here is pi over 2, pi over 4, and 3 pi over 4. And let's say this is 1, and this is negative 1. So pi over 4 is equals to, let's plot this pair, pi over 4, 1, pi over 4, 1, which is right here. At pi over 2 is 0, right here. And at 3 pi over 4 is negative 1, let's say right here. And if we connect these points, let me focus that right here. Right there. This is how the cotangent, the function cotangent of x looks like, you guys. All right, so notice all, remember, all we need those points. By the way, those are the key points that we're gonna be using to graph cotangent and tangent. All right, so any questions so far? Seems that we're good. All right, so really quick. So let's say that we wanted to graph the cosecant function, y equals to cosecant of x, right? So in order to draw the cosecant function, I know that cosecant is the reciprocal of the sine, right? So I'm gonna use that property, that identity right here. So I know that cosecant of x is equals to 1 over sine of x. So first thing that I'm gonna do, let me fix. I'm gonna draw the sine of x, the graph of the sine of x first, you guys. Oops, excuse me. So let's start by graphing the sine of x. Right there, sine of x, okay? And this is how I'm gonna graph it, sine of x. I know the sine of x, the period is 2 pi, right? So this is 1 pi and 2 pi. This is pi over 2, and this is 3 pi over 2, right? I know the amplitude is 1, right? 1 and -1. So let me draw these lines as guides. All right. So we're gonna draw the sine, but when we draw the sine, please do it very, very light. Like it could be a pencil or anything that would be very, very light. And let's draw the sine wave here, please. So the sine wave, I'm gonna do it in blue here. The sine starts right here. It goes up here. It goes down here. Goes down to 0 here, down in 3 pi over 2 goes down here and goes up to 0 here, right? So I'm gonna do it really, really, really light here. All right, so that's the sine of x. But remember that the cosecant is undefined at even values of pi. It is undefined at 0. It is undefined at pi. It is undefined at 2 pi. It is undefined at 3 pi. It is undefined at n pi. So since this is undefined, what I'm going to do is 0 is a vertical asymptote. Pi is also a vertical asymptote. So I'm going to draw a vertical asymptote right here. And also I'm going to draw another vertical asymptote at 2 pi. Again, the y-axis is also vertical asymptote. All right. Now we're going to draw the cosecant, the function. To draw the cosecant, this is what you guys are going to do. You're going to start at this point right here. And this vertical asymptote is going to help you as guides here. And you're going to start right here, and you're going to get closer and closer to this vertical asymptote, and also closer and closer to this vertical asymptote. And for the next second half of the period, now it's going to go this way. And now it's going to go this way. The graph in red is the function cosecant, you guys. The graph in red. But in order to graph it, I'm using the sine of x, something that I already know is going to help me to find the cosecant of x. And notice, the domain, as we said, is all the numbers except even values of pi, or n pi. I'm sorry, n pi. And remember the range of the cosecant, you guys? Remember the range? And let me write it here, the range. That was from negative infinity to -1, and from 1 to infinity. That is the range, you guys. That's why the range looks that way. And I think that now it makes sense. Okay. So if you have a couple of, give me a couple of minutes to grab the secant really quick. Okay. So notice y equals to secant of x. I don't know how the secant looks like, but I know that secant is the same as 1 over cosine of x. All right. I'm going to do exactly the same. I'm going to start by graphing the cosine of x really quick, you guys. And we know that amplitude is 1 and -1. So very, very light, graph the cosine. I know that the cosine at 0 starts with 1, and it goes down to 0. At pi goes -1. At 3 pi over 2 goes back to 0. And at 2 pi goes back to 1. So very, very light, you guys. Draw the cosine right here. Right there. Notice we know that the secant is not defined at odd multiples of pi over 2. So at pi over 2, we have a vertical asymptote. At 3 pi over 2, we have another vertical asymptote. All right, so now that we have that, I'm gonna draw the secant. The secant now goes this way. You start right here. It never touches this vertical asymptote right here. And go down here. And here at 2 pi, you go right there. The graph in red, you guys, the graph in red, that's the graph of the secant. So again, I'm using the cosine to get the graph of the secant. All ready? All right, so that's it for tonight, you guys, unless you have any questions. And we actually covered all the way to 6.5. We covered 6.4, 6.5, and 6.6. I gave you another exercise for 6.5. Give it a try. If not, we'll do it next time, you guys. So we know that we have a spring break next week, and I might assign a quiz. So I will let you know. All right. If you guys have any questions, somebody here send me a chat here. You're welcome, you guys. Thank you, you guys. And again, give me your feedback, okay? What we can do better, you know. And I think that we're doing fine so far, but I really need your feedback also. All right. Thank you for being here and keep safe and healthy, you guys. All right. So most likely I'm gonna upload a quiz for you to start graphing, you guys. All right. So have a nice weekend and next is safe spring break. And if you have anyone that has any questions, I'm gonna stay a little another 5 minutes here. Do you have any questions? You know, I'm here. And you know, thank you again, you guys. Good night. You're welcome, you guys. Good night. All right, you're welcome, Levi. So again, I'm going to post this video most likely tomorrow morning. All right, you guys, seems that you guys have no questions. Thank you very much. Good night, and we'll keep in touch. Keep safe.